This is our last video on kinematics without a calculator. Here we've got a couple of additional one-dimensional freefall problems. Let's try these. If launched from the ground, to what height will this object climb? Now, we're just making estimates here, remember. What we want to do is we want to use g is 10 meters per second squared in the downward direction. So it is going to take 8 seconds for this thing to get to the top. And to the top is what we're interested in when we're talking about to what height will the object climb. Well, at that point, isn't it true v final is equal to 0? So what's v average? It's 40 multiplied by 8 seconds. This is going to climb to a height of approximately 320 meters. 8 seconds multiplied by the average, did I write that here? V average equals 40 multiplied by 8 seconds. Let's try letter I. To the nearest 0.1 seconds, estimate the time for this object to reach the top. Well, if the acceleration is approximately 10 meters per second squared, then it's going to take approximately 4.3 seconds to get to the top. Letter J, how long would it take to return to its point of launch? Well, it would be double the time that it takes to get to the top. 4.3 seconds to get to the top, another 4.3 to come down, so that means 8.6 seconds. Let's estimate the vertical displacements here. And again, we're going to do these all in our head. We're going to estimate this by saying, okay, that's about 40, and that's about 2. So after 1 second, it's going to be traveling not 40, but 30. And then after 2 seconds, it's going to be traveling about 20. That means that V average is, I'll do a little bit of work here, V initial is 40, and after 2 seconds, it's going about 20. So our V average is about 30 meters per second times 2 seconds. That means it's going to go up about 60 meters. If we used a kinematics equation and put these numbers in, we would expect to get a number reasonably close to 60. Let's try the second one. We're not going to change the 0 meters per second because that's a really nice number, but let's change this to about 8. So we're dropping this from rest, obviously off the edge of a tall cliff, and V final is going to be, isn't it, negative 80, or 80 meters per second in the downward direction, because the velocity is going to change by about 10 meters per second each second. So that means that V average is going to be negative 40 multiplied by 8. So it's going to go downward. Any number of ways you could represent that, but it does ask for displacement. So we should either put a sign on it saying up here something like downward is negative if you want, or you can represent it with an arrow as I have at the bottom of the screen. Let's try a couple more. Initially V naught, let's say that's about upward at 30, and that time is about 5. So let's get our fingers out. Ready? Can you see my hands here? Yeah. Positive 20, positive 10. It's at the top at about 3 seconds. Then it's coming down at negative 10, coming down at negative 20. So V final is about negative 20 meters per second. So what's the average? Started at positive 30 and it ended at negative 20. So add those up, you get 10, you divide by 2. So V average is about positive 5 multiplied by 5 seconds. So the displacement is about 25 meters up, or positive 25 meters. Let's try one more. This V naught we're going to say is about negative 20. And we're going to say this is about 8 seconds. So here you go. I'm going to run out of fingers on one hand, but let's just do it with our hands here. Going downward at negative 20 after 1 second, negative 30, negative 40, negative 50, negative 60, negative 70, negative 80, negative 90, negative 100. Negative 100, that's V final, roughly. So what's V average? Negative 60 meters per second. Multiplied by 8 seconds, I'm thinking it's going to go downward about 480 meters.